Here we go. All right, the last problems we did yesterday where we had a polar coordinate and we converted it into a rectangular coordinate. Today, we're going to start doing the opposite. We're going to take an XY rectangular coordinate and convert it into an R theta, a polar coordinate. And then it's telling us, because polar coordinates are not unique, there's a bunch of different ways we can write it. Write your answer so that R is positive and that the theta is between 0 and 2 pi, which is the easiest one to find anyway, so that's good. Okay, so I have an X and a Y. Write those down here. And our job is to find R and theta. So we're going to start with R. You wrote these formulas down yesterday. R is the square root of x squared plus y squared. R is the distance to the origin. Think about it like the hypotenuse of a right triangle if you were to draw one. So in this case, it's 3 squared and 3 squared, which is 9 and 9, which is rad 18, which breaks down to what? 3 rad 2, and that's your R. Okay. Technically, it could be plus or minus, but we want the positive R. To get theta, there are actually 3 formulas that all have theta in them. The tangent one is the one that directly corresponds to what we know, x and y here. So that's the one we usually use. All right, so tangent theta is 3 over 3, or in this case, tangent is equal to 1. All right, so we want radians, so 0 to 2 pi. So this is just kind of like our trig equations that we solved in the last chapter. Where are 2 places on your unit circle where tangent equals 1 in radians? Okay, one of those is right and one of those is wrong. And how you know which one is correct is we said that this point that I'm writing should be in the same location as my original point. My original point is in what quadrant? Quadrant 1. So if you know that, you know your angle that you're looking for is also in quadrant 1. So we know that pi over 4 is the correct answer. So final answer then is R, which is 3 rad 2, theta, which is pi over 4. Make sense? Okay, so let's do the other one real quick. What quadrant is that guy in? Quadrant 3. Okay, so I know eventually when I get to my angle part, I'm going to be looking for an angle in quadrant 3. Solving for R. Square root. -2 squared plus -2 rad 3 squared. -2 squared is just 4 plus, now squaring that next one, it's multiplied, so you're allowed to distribute the squared in. So -2 squared is just 4, and rad 3 squared is just 3. So it's going to be 4 times 3, which will be 12. So 12 and 4 give me rad 16, and the square root of 16 is 4. So that's your R. To get theta, I'm going to do tangent. Tangent theta is y over x, -2 rad 3 over -2, or just rad 3 over 1 if I cancel those -2's. So you've got to figure out where on your unit circle do you have a y that would give you a rad 3 over 2 would be on top, and an x that would be a half. And we know we're in quadrant 3, so they're both going to be negative. So where does that happen at? Let's see, 7 pi over 6. Yeah, that sounds good. No. Yes. What am I looking for? My y is rad 3 over 2 and my x is a half. I think the other one's what we're looking for. 4 pi over 3. We want this scenario where we do rad 3 over 2 divided by a half. So the y would be negative rad 3 over 2. The x would be negative a half. Okay. And then that's it. 4 pi over 3. Okay. Yeah.
How do you know that the square root of 16 is 4?
Because in the instructions, we want R greater than 0. It could be plus or minus, and we could list it another way, but for these, you're always just going to get the positive R. Okay? Any questions? Okay, so that's the other way to convert points. All right, now, We can convert points. We can also convert equations. So this equation, if you want to write it down, x squared plus y squared minus 2y plus 3 equals 0. It is in what we call rectangular form. We want to convert it to polar form. So pretty much we just need to figure out how can we make the x's and y's into r's and thetas. And we're still using those 4 formulas again. So if you want all 4 of those formulas on that paper you have, guys, we had this one yesterday. R squared is x squared plus y squared, which you could take one step further, like this. We had tangent theta. Tangent theta is y over x. We had x equals r cosine theta, and we had y equals r sine theta. So that's what we're using in these conversions, all 4 of those, okay? So we're just finding things that we can replace. Like in this one, I have an x squared plus y squared. What is x squared plus y squared equal to? It's r squared. So I can just replace it with an r squared. The only other thing that's not polar right now is this y. What is y equal to? R sine theta plus 3 equals 0, and that's your answer. As soon as you have it with r's and thetas instead of x's and y's, you're done. The polar equations, we're not looking for a particular form. There's not like something we have to make sure is alone or anything like that. So that's it. These are pretty straightforward. Just replace what you can until it's all r's and thetas. Okay? Then let's take a look at converting the other way now. Now for these problems, we're not going to be graphing on the polar graph with all the circles. You would just need like a generic little XY plane, so you can just sketch that on your paper. We want to take something that's polar, r equals 2 for this first one, convert it to rectangular, x's and y's, and then once we've got x's and y's, it should be a graph that we recognize like probably from last semester, like lines and circles and things that you were starting to graph a little bit on your packets last night. Okay, so what is r equal to in rectangular form, in x's and y's? What can I replace r with?
We're at x squared plus y squared.
Yep. Okay, and it almost looks like something that we saw last semester if you just take it one step further and square both sides. X squared plus y squared equals 4. That is a standard form of something. What's it the standard form of? That's a circle. And if it's a circle, you only need 2 things to graph it. You need its center and you need its radius. Can you tell me what the center of this circle is? The center is the numbers that are subtracted from the x and the y, which we don't actually have anything subtracted from the x and the y here. So what are those numbers? 0, 0, 0 is the center here. You could write, if you guys remember, x minus h squared, y minus k squared, that's the form. And then r is what? 2. Okay, and this is where you kind of start to see some similarities. R is 2, it means a circle with radius 2 at the origin. So to graph it, I would just make a point at 0, 0. I would go 2 in every direction. And then I have my graph. So if I said r is 5, you should be able to now picture that. That means a circle centered at the origin with radius 5. That's what it would look like as a polar graph. Okay. All right, let's do another one. This one, we've just got a theta. There's no r. So theta equals negative pi over 3. All right. There's only one formula out of the 4 that just has a theta and doesn't have an r in it, and it's the tangent one. So I'm going to use that. In order to use the tangent equation, I need to take the tangent of both sides. I'm going to take the tangent of theta, which is tangent theta, and I'm going to take the tangent of negative pi over 3. Now what you see on the right there is something that we should be able to figure out with our unit circle. Is tangent even or odd? Odd. So what can I do with that negative? Bring it to the front. Okay, can you tell me what the tangent of pi over 3 is? The y divided by the x at pi over 3. What is it? Rad 3. That's it. So negative rad 3. Okay, remember we're trying to write this with x and y's. What's tangent the same as? What's our formula? Y over x. equals negative rad 3. If you don't recognize something that's in rectangular form, if it's not a circle, if it's not square, the easiest thing to do is get the y alone, because that's usually how we graph things, right? So if I get the y alone, it's negative rad 3x. Can you tell me what this is the graph of? It's just a line. Yep. The rad 3 is kind of a gross number, but this is just slope-intercept form. It's a line that has a slope of negative rad 3 and has a y-intercept of 0. Put a little plus 0 at the end if you want to see that. Okay. So graphing it, I'd make a point at the origin, and then I'd have to go down rad 3, which is about 1.7, and then to the right 1. So my line's going to look something like that. Now imagine on your unit circle where negative pi over 3 is. Negative pi over 3 is negative 60 degrees. It's this right here. Do you guys see the relationship? Okay, so all we're getting, if we just have an angle, is the line that will correspond to that ray on our unit circle. We just extend it through both quadrants. That's an easy way to check to make sure those answers are right. Okay, we got 2 more of those. Okay, r equals secant theta. All right, we don't have a secant in any of our conversion formulas, but what do we have? A cosine. So secant's the same as 1 over cosine. I'm going to get that cosine out of the denominator. I'm going to multiply both sides by cosine. R cosine equals 1. What is r cosine equal to? X equals 1. What is that the equation of? A line. What kind of line? Vertical line. If it's x equals, right? If it's y equals, it's horizontal. So that's all you have to do is draw a vertical line at 1. For that one. All right, and then last one, r equals 2 sine theta. This one's tricky because I have a sine, but it doesn't have an r next to it. If I had r sine, I could make it into a y. It would also actually be nice if my r was squared on the other side. So really, both sides of this equation, if we had an extra r, our life would be better. So a good start here would just be multiply both sides by r, because then I have an r squared, which is good. I can change that. And I have r sine, which we know is equal to y. R squared is equal to x squared plus y squared. Okay, it's all x's and y's. That's good. What is this the equation of? This is also a circle. Here's the problem though. You don't have the circle in standard form right now. So we're going to put it in standard form, which involves completing the square. We did this last semester. Quick recap. Get your x terms and y terms together. So I'm going to move that y over. Minus 2y equals 0. Okay, then the x is pretty much done. I can write x minus 0 squared, and he's already in standard form. He's all set. The y is what's the problem here. So to complete the square, we take the number that's in front of our linear term, negative 2, and we half it, square it. Do you guys remember doing that? Half it, square it. So if I half negative 2, I get negative 1, square it, I get, so we're going to add 1 to both sides. If I add 1 on to the right, 0 plus 1 just gives me 1. And now those 3 terms you've created should factor into a binomial squared, a parentheses times itself. What does that factor to? Y minus 1 squared. My computer's being really slow right now. Y minus 1 squared equals 1. There we go. Okay, that is standard form now. What's the center of the circle? 0, 1. Just the opposite of the numbers that you see with the x and the y there. The radius is the square root of whatever's on the right side, which is just 1. So we have a circle centered at 0, 1, so on the y-axis, and then radius 1. So just go 1 unit in every direction to get that picture. So those 4 should give you an example of each type you're going to see on the Math Excel then. So if you get to a Math Excel problem that's asking you to convert, you can probably use one of these 4 as an example step by step to get through it, okay? Yeah.
Where do you get like that x minus 0 squared?
It is x squared. I just wrote it in that form so you can see the standard form a little nicer, right? Subtracting 0 doesn't change anything. You don't even have to write the minus 0 squared if you don't want to. But you only need to complete the square if you have more than one of a variable. Like I only have an x squared, that guy I don't have to complete the square with. But the y's, I had a y squared and a y, so you have to complete the square to get it in the right form. Okay. Sometimes you do it with both variables, sometimes just one. Any questions on that? Okay, we're gonna do one graph by hand of a polar graph. So find a graph on your paper there with one of the circles that we haven't used or you haven't drawn on or something yet, okay? So we're going to kind of see what happens when your graphing calculator graphs all of these pictures. When it comes to like quiz and exam time, you are not going to have to graph these by hand. It's going to be more of like a matching type situation with the type of graph and what it creates. Same thing with Math Excel, but I just wanted to show you one where it came from. So we make tables of values just like we do with normal graphs. Instead of x's and y's, it's r's and thetas. The first equation, well, the only one that we're going to graph is r equals theta, okay? Which means whatever my theta is, my r is going to be the same thing. There's not really a whole lot to plug in here. So if theta is 0, r is 0, okay? And we just choose common values of theta that are easy to use. You can count by whatever you want. Like I could count by pi over 6s if I want. I could count by pi over 4s. I'm just going to count by pi over 2. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. That's just like every pi over 2. I'm picking a number. Okay, just setting up a table. Okay, and then in this case, I, again, don't really have a whole lot to plug it into. Theta is whatever r is. So the bottom of the table is going to look the same. Pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Now you'll notice on my polar graph, you can count by whatever you want as far as the radii of these circles go. I have to graph pi's here, so I counted by pi's. 1 pi, 2 pi, 3 pi, 4 pi. But if you just had numbers, you could make it just 1, 2, 3, 4. You can make that polar axis whatever you want. That's just how wide your rings are, okay? All right. Now graphing the points, this is like what we practiced yesterday. 0, 0, that one's pretty obvious. That one's going to be at the origin. Okay, right there. That's my first point. Pi over 2, pi over 2. So the first pi over 2 refers to the angle, which would be going up on the y-axis. We know where that is. The second pi over 2 tells us how far we are from the origin. So I know I'm going to be here. That's where pi over 2 is. And then I want to be pi over 2 units from the origin. Well, pi units from the origin is the first circle. So pi over 2 would just be halfway between the origin and the first circle. So that's where my point's going to be. So it's going to be on the y-axis, halfway between 0 and pi. Okay, the next point is pi, pi. Well, we know pi is on the left side, right? And I am pi units away. So I'm on the first circle. 3 pi over 2 is going to be at the bottom. And 3 pi over 2, you can make like 1.5 pi. So I'm between the first and the second circle. That's where my point goes. 2 pi, I'm at 2 pi. So that's on the right side. And then you can keep going. You'll notice there's a pattern here. 5 pi over 2. Each time we're just making another quarter rotation and we're getting a half a unit further out. So this doesn't look like a whole lot of anything, but when we create the polar graph, then we just connect our dots with a curve in the order that we plotted them. So if I start at the origin and just with a curve, just kind of slowly start going from one point to the next, you see this like spiral start to show up. This is not one of the ones you had in your packet last night. It's an example of a type of polar graph we can get. Okay, and changing what the equation looks like slightly, like if I put a 2 there, it actually dilates it. It makes the spiral wider. Or if I put a 1/3 in front of my theta, it makes the spiral tighter. So there's different things that you can then do to manipulate the basic equations to transform them, like we talked about transformations before. Okay. All right, so that's in general how you would do a polar graph by hand. We don't spend a ton of time on that though. All right, take out your packets from last night. Let's just kind of talk through the different types of graphs. that you have. Let's see here. Okay, so I don't have on here what your pictures should be at the top of each page, but I have what your answers in the summary part should be. And you might have exactly this or something that kind of sort of sounds like it. That's fine. Okay, so for the first page, you should have seen circles for all of them. The A value in the equation represents the diameter of the circle. If they are sine graphs, they end up being above or below the x-axis. Think about sine as our y's, right? Does that make sense? Above and below. And then cosines, they end up being left and right. Okay? If it's positive, it's to the right. Negative, it's to the left. And if it's positive, it's up. Positive or negative down. Okay, so for like the ones at the bottom, then I could say, okay, well, it's a sine. So I know it's going to either be above or below. Because it's negative, it's below. Because it's a 4, the diameter is 4. So that's how you could maybe kind of like fumble your way through it to be able to just make a rough sketch. Okay, for the second one, it's a cosine. So I know it's going to be either left or right. Cosine is my x. It's positive, so it's on the right. It's a number 6, so my diameter is 6. Okay. Any questions on that? Okay, next. Second page was the ones that were pretty. These were our flowers. They're actually called rose curves is the official name of these. So if you had flower or rose, that's fine. The A value in the equation represents the length of the petals. Okay? And then the B value helps you figure out how many petals there will be. There's actually 2 different scenarios. If B is an odd number, it has that many petals. So if B is 3, there's 3 petals. If B was 7, there were 7 petals. If B is an even number, there's double that many petals. So if B was 2, you should have saw 4 petals. Or if B was 4, you should see 8 petals. Number 8, sine and cosine, actually just different from each other. These are a little harder to see because of the symmetry with these, but it's a rotation of 45 degrees away from one to the other. The easiest way to tell if it's sine or cosine when you're looking at a rose curve is to look on the positive side of the x-axis. If it's a sine graph, there will not be a petal on this side of the axis. If it's a cosine graph, there will be a petal on this side of the axis. So if you look back at all those at the top, all the sine graphs do not have a petal on the right side of the x-axis. All the cosine graphs do have a petal on the right side of the x-axis. Okay, so those are rose curves. The third set, these make up a set of what we call limacons, and a cardioid is an exact name for this. If you had like a heart shape or like a dimple graph, I mean, you can call this whatever you want. I did not expect that you knew it was called a cardioid. Okay. There are 2 types of limacon graphs. Ones that have an inside loop and ones that do not have an inside loop. So you should have just kind of matched those up. And then notice the ones that have an inside loop, A was less than B in the equation. And the ones that do not have an inside loop, A was greater than B, where A is the number in front and B is the number in front of the sine of the cosine. And then at the bottom, you can figure out what do A and B need to be for this to happen. Well, it actually gives us A and B. You had to figure out where does the loops go, I'm sorry, to 7 and 3. So something like that. Okay, you add to 7, subtract to 3. That's how we can figure out where the curves are going to go. And then on the back, this was just matching with your graphing calculator. So if you got stuck, hopefully you just use your graphing calculator to match them. All this is posted on Polaris for you, by the way. Okay, so here's 1, 2, 3, and 4. I didn't put any like letters or anything on those. And then below that, there's those. R equals 2 and theta equals pi over 3. We saw ones like that in class today. They weren't your cat. I'm going to give you guys each this. This is a great little handout that shows all the different kinds of graphs and what the values in the equation need to be to make those graphs. So this will be a good little source of reference when you guys are looking to do your homework, okay? Tomorrow we're going to do 7-7, which is our last section in chapter 7. We have one like extra section we do next week that our state has us do, but the last thing, it's complex numbers. we're going to talk about. 7-6 Math Excel is due on, let's see here, Monday night. Okay, so tomorrow we're going to do 7-7. Monday is a Math Excel work day. You guys can work on 7-6 or 7-7 on Monday. And then Tuesday is going to be our last quiz. Partner quiz, open note over these last two sections in chapter 7, 7-6, 7-7. So that's what's coming up in the next few days. Okay?
This is the homework that's due on.
7-6, what we just finished, is due on Monday. And then 7-7, I think, is due on Tuesday night, maybe. Those are your last two Math Excel. 7-6. Yeah. All right, we got about 3 minutes. Let me do cell phone lotto for you. 21. Nobody today.